Hi, my name is Amrita Kosanam and I'm a junior at Tompkins High School in Katy, Texas. So today I'm going to be demonstrating 3 group testing methods, and the first one is called the Dorfman method. For this, we're going to be testing 8 individual samples, and one of these samples is going to be an infected sample. And I'm going to represent this using a clear glucose solution. For the other 7 samples, they will be non-infected, and I will just be representing these using some distilled water. Now I'm going to fill in the individual samples, and I've selected one to serve as the infected sample. So now I've filled up all of the individual test tubes, and I'm going to be creating 2 pooled tests. I'm going to put individual samples 1 through 4 in my first pooled test, and then individual samples 5 through 8 in my second pooled tests. So I have a test tube labeled D1, so this is where samples 1 through 4 are going to go, and I'm taking about half of an ml and putting this into the pool. I am using different syringes for each test tube, and this is to reduce any chances of cross-contamination because for the pooled test that will not have any kind of glucose solution in it, we want to make sure that that stays completely yellow to kind of reflect how that does not have the infected sample in it. Okay, so now I've created the 2 pooled tests, and I have 2 test strips here, and I'm going to test each of these pools, and I'll have a table here to demonstrate. So just before we get into the test strips, I just want to demonstrate what a negative test strip versus a positive test strip looks like. So for a negative test strip, the original test strip is actually yellow, so as you can see here, and it's going to stay yellow because there's no glucose in it. However, if we're testing it on some solution that has glucose in it, it is going to turn some shade of green. Now, the shade of green depends on the concentration of the glucose. So if it's a high concentration, it'll be a lot more dark. And if it's a low concentration of glucose, it'll be kind of a lighter green. So that's for your reference for the test strips. Now, for the Dorfman method, I am going to be testing these 2 pools. So here's my first pool, and I'm placing that right here. And then my second pool is going to go right here. I'm going to start a 30-second timer, and then after 30 seconds runs out, okay, so 30 seconds has run out, and as you can see here, the test strip for my first pool test actually remained yellow, while the test strip for my second pool test is actually green. So what this tells us is that we need to take the test pool 2 and we need to progress that to the next step, which is where I need to look at, well, which samples went into this pool, and that was 5, 6, 7, and 8, and I need to individually test 5, 6, 7, and 8 to see which one of these is actually the one infected sample that I selected at the beginning. So what I'm going to do now is I have 4 test strips here, and I'm going to be testing test tubes 5, 6, 7, and 8 individually, and then we're going to see the results. So from test tube 5, and just to show this visually, what I'm doing here is the first individual test is right here, and then I'm gonna take test tube, the first individual test is going to line up with test tube 5, second individual test with test tube 6, third individual test with test tube 7, and then 8. So now I'm just going to repeat this for the rest. Okay, so 30 seconds is up, so now let's look at the results. The test strip that turned green, so the one that had glucose in it, aligns with what we did with test number 5. So this is that first individual test, and as you can see, we actually placed sample 5 in it, right, like this. So this is significant because we actually were able to use only 6 tests and determine that one infected individual out of a total pool of 8 people. Okay, so now I'm going to be demonstrating another method called the binary method, and this is way different from the Dorfman method in that the methodology that I'll be using in order to sort these 8 individual groups into their respective pools is a little bit different. So as you can see here, I'm actually looking at how numbers 1 through 8 are represented in binary. So if we look at this here, number 1 is represented in binary as 0001, or number 7 is represented in binary as 0111. And this is actually significant when it comes to putting these tests into pools, because if we look at if we go across these rows horizontally, well, we can see which samples have a 1 in this row. And if the sample has a 1 in that row, that means that we are going to put it into that pooled test. So each of these rows represents a different pool test. So for example, pool test number 2 is going to have samples 4, 5, 6, and 7 in it. Or pool test number 4 is going to have samples 1, 3, 5, and 7 in it. And pool test number 1 is going to have pool test 8 only. So that's how we can see, well, what samples went into what pool test, and then we can kind of track based on those results which sample is the infected sample. So here I have my 8 individual samples, and I'm going to start off by creating my first pool test. I labeled it test tube B1, and this has sample number 8 only. So I'm going to take 0.5 ml, just like with the Dorfman, and put that into this test tube. And then so on with B2, which represents the second pool test. This is going to be 4, 5, 6, and 7. So 0.5 ml from each again. And then my third pool test, which is going to have samples 2, 3, 6, and 7. And then my fourth pool test is going to have samples 1, 3, 5, and 7. Okay, so now I've completed all 4 pool tests, and I'm going to have one test strip, and I'm going to test each pool. So this is for my second pool test for the third one, and then the fourth one. Okay, now I'm just gonna start the 30-second time. Okay, so 30 seconds is up, and now let's take a look at the results. So we were actually able to see that pool tests 2 and 4 had samples that turned green. So I'm actually gonna mark these right here. So this is actually significant because this can tell us which sample was actually the one that was infected. Because if we look at which samples that we put each number into, so for example, I put sample 7 into pools 2, 3, and 4, but not 1. So that means if sample 1 was hypothetically the infected sample, then only pool test 2, 3, and 4 would turn green, right? So we actually need to look at the individual sample that only went into test pools 2 and 4. So I have to look for a binary combination of 0, 1, 0, 1. So I'm going to look here and I'm going to look through them. Well, that seems to be sample number 5. So sample number 5 was actually the infected sample in this case, and we were able to look at the binary in order to tell us that. So now I'm going to be demonstrating the row column method, and it's going to be a little bit different than how I showed the Dorfman and the binary method because instead of just 8 individual samples, I'm actually using 16, and I've arranged these 16 samples in a 4x4 array. In addition, we're not only going to have one infected sample, but 2, and these infected samples are actually going to be represented using glucose solutions of different concentrations, meaning one individual sample will have a higher concentration and the other individual sample will have a lower concentration. And this will kind of enable us to simulate how the situation would be in real life, where one person may have a different viral load than another person may have, even though both may need to be tested for this disease. I'm going to be creating 8 pooled tests at the end of this experiment, and these pooled tests will be comprised of the 4 test tubes that are in that row or column. So I'm going to have 4 row pooled tests and then 4 column pooled tests, and then we'll be able to see the results at the end. For now, I'm going to be filling in the individual samples with their respective solutions. Okay, so I've gone ahead and I filled in all of the test tubes with their individual solutions, and now I'm going to start by creating the pool test. So here I have the test tube for my first row pool test, and I'm just going to be taking all of the samples from the test tubes in row 1. All right, so that's row 1, and then same thing, but with okay, so now same procedure, but now I'm just going to finish all of the 4 columns. All right, so those are all of our 8 pooled tests, and now I'm just going to go ahead and test using a test strip, and then I'll lay them out here on this chart. Now same thing, but for the columns. So now I'm just going to start the 30-second timer and then allow those test strips to develop. Okay, 30 seconds is over. Now let's look at the results. So I'm gonna go in and match the samples where the test strips turned green so that we can look at where they could be infected. So right here, right here, right here, sample number 42, and then 39. But at the beginning I said that I actually only put in 2 infected samples, but here we have 4 possibilities. So now we have to kind of look at, well, which ones are the 2 that don't count? So I'm gonna look here and see, well, one sample can have 2 different concentrations, so we just have to look at where the test strips match up and where they're both either light or dark. So I'm going to look here first with sample 31, and we can see that the test strip is actually dark for the column and dark for the row. So I can say that this is actually one that's actually infected. Here for sample 34, the row seems to actually be pretty dark, whereas the column test is pretty light. So I'm going to say that that's not one of the correct infected samples. Sample number 42, I have the row looking light and the column also pretty light. So I'm going to say that that is an infected sample. And then for sample 39, the row test is looking lighter, but the column test is actually looking a lot darker than that. So I'm going to say that this is another one of those incorrect samples. So looking at the different concentrations, we were actually able to test 16 individuals using only 8 tests.